Welcome to Chemistry Tales. We're going to review the physical states of matter, starting with the solid phase. Here, the atoms and molecules are packed closely. There's strong intermolecular forces attracting those items to each other. And if we apply a large pressure, we will not see a big change in volume. In the liquid phase, atoms, molecules, or ions are further apart. It's a fluid. It will flow to conform to the shape of any container. And the strength of the intermolecular forces is intermediate. If we apply a pressure, we see little to no change in volume, so it's incompressible. Finally, the gaseous phase. Atoms, molecules, or ions are very far apart. They have high kinetic energy. They're moving, high translational energy, and because they're so far apart, when we apply a pressure, there's a big change in volume. So we're going to focus on the solid and liquid phase in this chapter. Those are the condensed phases. One of Annie's favorite states of matter is solid. She loves ice cream and cheese. Those are emulsions, which are various forms of the solid phase. Okay, moving on to our next topic in our chapter on liquids and solids. We wish to give consideration to phase transitions. For each, we're going to identify the process that happens, the name, and the sign on the enthalpy change. First, if we go from a solid to a liquid, that's called melting. We also refer to it as fusion. The enthalpy change is positive. It's positive because we have to add energy to break the intermolecular forces. The symbol is delta H fusion. Liquid to a gas is vaporization. It too has a positive enthalpy change because we are breaking intermolecular forces. And the enthalpy is delta H vape. We can go from the solid directly to the gas. That's sublimation. It's the combined processes of the two previous, that of melting and vaporization. So the delta H is the sum of those two things, and it is delta H sublimation. The reverse processes, going from a gas to a liquid, is condensation. Think of dew droplets on a leaf. The sign is negative because we're forming intermolecular forces. That's more stable energy is released. And the sign is opposite of that of delta H vape. Liquid to a solid is freezing or crystallization. It too has a negative enthalpy change because we are forming intermolecular forces which are stable. Energy is released, and the sign is opposite that of the melting or fusion. We can go directly from a gas to a solid. That is deposition, and that is the sum of the two previous processes in which the overall magnitude of the delta H is the sum of the previous two, but opposite in sign. So that is a quick summary of all the possible phase transitions and the affiliated symbols and energy relationships.